So void main has been opened. This is the main function. Now we are going to declare the ports. As the basic architecture of 8051 goes, it has 4 ports: port 0, port 1, port 2 and port 3, all of 8 bits wide. So now I am going to use port 1 and pin 0 to connect the LED. So the LED connected to port 1 and pin 0 should blink. That is the target of my code. And now to indicate port 1, I am going to use capital P1 followed by 0th pin is indicated by 0.0. Suppose I am going to use port 1 pin number 2, I should just give port P1.2. So for now I am going to use port 1.0, that is the 0th pin, equal to 1, that is logic 1, semicolon, terminating terminator for the line. Next followed by delay. So delay is the program, and the time duration specified in the delay program will be the time duration for which the LED connected to pin port 1.0 will be on. So this delay will define for how long should the LED be on. So I am going to give delay is an additional function that is to be written, and let us write it at the end of the program. Now followed by port 1.0 equal to 0. Now I am giving logic 0 so that the LED is off. Again I am going to give a delay which will tell the controller for what duration should the LED be off, and close braces. Now I am going to give the function delay int I for I equal to 0, I less than or equal to probably 500. So actually this value will determine how long will your duration or the delay time be. I am giving 500. Any numerical value can be given. When you reduce the numerical value, the delay becomes very brief, and you cannot even probably visualize the blinking of the LED. It will seem like a fastly screening thing. So 500 is a nominal value. 500 I plus plus. So inside the for loop I am giving just a semicolon indicating that it is a dummy statement. A dummy statement is very analogous to NOP, no operation, of the 8051 microcontrollers instruction set. So now I am closing the delay function. Because we have used a subfunction titled delay, we have to declare it above the void main. So I am going to give void delay terminated by a semicolon. Now I am segmenting the code: header file, subfunction prototypes, main function followed by the subfunction. The problem here is that the code inside this void main will be executed only once. For this to happen repeatedly, what we are going to do is we are going to put it in an infinite loop. Infinite loop is a loop which will never end, and it will always keep executing the statements inside it. So to give an infinite loop, it is very customary to use while statement. That is what I am going to give it here now. Watch keenly. While 1, open brace, inside the braces we have close brace. So this statement or this block means that always execute. That is what the meaning of this block. Now while 1, that is the condition is always true. While the condition is always true, keep on executing this statement. So that is what has been written here. Now the program is full-fledgedly completed. See what happens. Click save. You get the folder in which you have saved your project. Save the title of the C file in the same name as your project to avoid confusion. So use Blinky And don't forget to specify the extension as .c. This is not a C++ program, this is a C program, embedded C program, so we are giving blinky.c. And now click save. You can see that the program is appearing in colors, which is indicating the variables, constants, and everything, syntaxes, everything. So now what you have to do is, only the booting file for the 8051 architecture has been included into the source folder, but our C program has not been included into the source folder. So to couple this 8051 booting file along with this C file, we have to click on the source group folder. Right click on it, click add files to source group 1. You get a folder that you have created already in the name of your project. Blinky.c is what we have saved. Double click it. You will see that blinky.c is appearing on the right pane. With that, you can close this dialog box, and all the source files necessary for your project have been added here. So again, click save. This tab is for translating the current file. So translating means the compiler will translate this C file into assembly file. While translating, you are getting a number of errors. The problem is syntax error near point O, delay redefinition. So probably what you can do is, you can cut this delay program and place this before the void main program and name it void delay. Now click save, click compile. The errors have been reduced. Syntax error near point 0. So maybe probably this point 0 is not compatible. Many compilers support this point 0, that is definition of the pin number with a point. So let us give it as _0. So this is all trial and error. So port 1 _0 indicates port 1 pin 0. Click save again and compile. Now you get build the project. Now you get blinky.c, 0 errors and 0 warnings. So no errors, no warnings. Now the next tab found over here is build the target. We have to build this file. Click build. You get 0 errors, 0 warnings again. Now click rebuild. You get 0 errors, 0 warnings again. So with that, it shows that your project is pure and complete in all respects. Click this, get into this blinky.c. You can find the header files included here, stdio.h and 8089x51.h. Now what you have to do is go and click this debug button. This is an evaluation mode that I am using with code size 2 kilobytes. 2 kilobytes of program will be a very big program. This is a very normal and a very small program. So this will very well run on the simulator. Click OK. Now to visualize the status of the ports, you have to go to peripherals. Peripherals will show the on-chip peripherals available for this chip, that is 8089C51. For this particular chip, you have interrupts, input output ports, serial port, and timers 0 and 1. What we are working on now is input output ports. Input output ports, there are 4 ports, port 0, port 1, port 2 and port 3. Now we are using port 1, that is 0th pin, port 1 0th pin. So click on port 1. You can see a very beautiful appearance of all the 8 bits clearly indicated from MSB to LSB, that is bit 0 to bit 7. Initially all the ports are configured as output ports sending FF, that is all the bits high. This is the basic status of an unprogrammed 8051 chip as per its standards are concerned. So now we are going to run the program and see what is its output. Take the cursor. You have a tab here titled run. Click run. You can see that the 0th bit of port 1 is blinking alternately. So probably when you connect an LED to this 0th pin of 8051 port 1, you will have the LED blinking like this. A small modification of this program can be done, but before that we have to stop this execution by clicking the stop button. and then we have to get out of the debug session. Click it again, you get out of the debug session. Now let me modify this program to output logic 1 on all the pins of port 1 and followed by logic 0 on all the pins of port 1. So port 1 will blink to 00 to FF alternatively. So a small modification is enough for that. Now click here, remove this pin specification. This means that port 1 as a whole we are specifying as 0xFF, hexadecimal FF, which means all the pins are high. Port 1 is 0x00, hexadecimal 00, which means all the pins are low. Now click save. Again build, translate, build and rebuild. Click debug, give OK. Now the port 1 appears. Now click run, see what happens. The total port is blinking. So this is how you are going to use port 1. Now the problem is getting the code ported into your hardware. So how it will be done? You have to go to Flash, configure Flash tools, target. In the target the maximum frequency has been specified, but for the board is concerned we are going to use only 11.0592 megahertz. So change it to 11.0592 megahertz. Go to output, click create hex file and give OK. Now again save the project, translate, build it, rebuild it, debug it, run it. Check the output. Please stop the running process, get out of the debugging session and minimize the project. Now go to the place where your project was stored. To find that you can look at the border of the KEIL Microvision 3 window. Now go to that folder. Usually it is in the C:, KEIL folder. Here it is, the folder titled Blinky. Now you can find the hex file for your project. So this is the hex file for your project. If you burn this hex file into the flash memory of the 8051 microcontroller, your microcontroller will work according to your program. So this is how you have to get started with KEIL Microvision 3 to program your 8051 microcontroller. In the forthcoming tutorials, let me tutor you how to burn a microcontroller, that is write the hex file into your microcontroller and work on other peripherals like serial port, UART and timers and counters, etc. So but for now this is the kickstarting tutorial that will give you an ignition how to work with KEIL Microvision 3. Thanks a lot.